येतोय आवाज?
हो हो हो.
Okay. So, what are the things that we have discussed so far? We discussed what is wave. Wave is a disturbance. Wave is a mechanism with which, with the help of which we can transfer energy and momentum without the actual transfer of matter. Waves can be classified into two waves: mechanical waves, non-mechanical waves. Mechanical waves require medium. Non-mechanical waves do not require medium. Again, mechanical waves. Forget non-mechanical or electromagnetic waves. Can be classified in different ways. They can be classified. Hmm? These mechanical waves can be classified based on different bases. If we consider direction of vibration and direction of propagation, based on that, they can be transverse or longitudinal. There is second way of classification based on dimensionality. If energy propagates only in one dimension, two dimension, or in all three dimensions, based on dimensionality. And based on particle behavior in time, means particle oscillates for a time interval, then stops, then we call it as a wave pulse. But if it keeps on oscillating forever, if it keeps on oscillating forever, in that case, we call it as wave train, wave pulse and wave train. These are the things that we have discussed so far. Then we also discussed that if we have longitudinal wave, of course we are talking about mechanical waves. We are not talking about non-mechanical or electromagnetic waves. These mechanical waves can be longitudinal or transverse. Non-mechanical waves are always transverse, but we are not talking about them. Mechanical waves which can be longitudinal or transverse. These longitudinal waves require bulk modulus and transverse waves require modulus of rigidity. Now, bulk modulus is available with solid, liquid and gas. But modulus of rigidity is available only with solid, not with liquid and gas. So longitudinal waves can be in solid, liquid as well as gas. But transverse waves are produced or can sustain only in solid. Reverse analysis: solid, liquid, gas. Solid has both bulk modulus and modulus of rigidity, so it can sustain both longitudinal as well as transverse waves. Liquid has only bulk modulus, so it can sustain only longitudinal. Gas has only bulk, so it can sustain only longitudinal. But if you read this statement, ripples on the surface on the surface of the pond, not inside the pond. They're not talking about liquid which is inside. They are talking about liquid which is on the surface. They are neither transverse nor longitudinal, but they are a combination of the two. Means if this is the surface and if you drop stone here, you will see ripples coming out like this. If you check any one position, the direction of propagation of energy is like this. Direction of oscillation is neither parallel nor perpendicular. It is combination of the two. Means there are two SHMs which are simultaneously acting on that particle. Means this particle has oscillations along horizontal direction as well as vertical direction. So resultant motion will be ellipse or elliptical motion, clockwise or anti-clockwise depending upon the phase difference. So if you if you throw a stone in the pond, there will be ripples, and on the surface of the pond, if you place a small object, You will observe that object is not moving up and down. Object is not moving forward, backward. The object is actually circulating like this in the vertical planes. It is not moving up and down. It is not transverse wave. It is not moving forward, backward, parallel to surface. It is not moving perpendicular to surface or parallel to the surface. It is performing elliptical motion. So it is a combination of both. Now you will say, sir, how can a transverse wave be present in the liquid? You're right. Transverse wave is not present in the liquid. It is present on the surface. The liquid surface behaves as if it is a stretched elastic membrane. The liquid surface behaves as if it is a stretched elastic membrane. And yes, stretched elastic membrane has both bulk modulus as well as modulus of rigidity. So on the surface of the liquid, you will have both beta as well as eta, or B as well as eta. Bulk modulus as well as modulus of rigidity, both are present. So on the surface, you can have both transverse and longitudinal waves, but inside the liquid, you will not have modulus of rigidity. Inside the liquid, you will not have modulus of rigidity. Yes or no? Inside the liquid, you will not have modulus of rigidity. So inside the liquid, the waves will be only longitudinal. On the surface, they can be both transverse as well as longitudinal. Wave function. What is a wave function? Wave function is nothing but equation of oscillation of particle. The problem here is there is not one particle which is oscillating. There are n number of particles which are oscillating. Generally, equation of oscillation means what? X is equal to A sine omega t plus alpha. Now instead of X, they will call Y. So Y is equal to A sine omega t plus alpha. So equation of oscillation of the particle is basically function of time. That's it. But the problem here is it is not the one particle which is oscillating. There are n number of particles which are present here, and all of them are oscillating. What does that mean? All of them are oscillating means what? The oscillations are not only function of time, they are also function of position. Oscillations are present at each and every position in the medium. But all the oscillations are not in phase. Everywhere oscillations do not start simultaneously. First, the particle at x1 will start its oscillation. And after some time, wave will reach at location x2. Then it will start its oscillation. So when this particle is at the phase of 90, this particle is at the phase of 0. Means the particles which are ahead are actually lagging in the phase. If the wave is traveling rightward, these rightward people are lagging in the phase. Because wave reaches there at a later instance of time. थोड्या वेळानं wave तिथं पोहोचते. Do you understand this? Then the wave equation of a traveling wave. Waves can be of two types again. Traveling wave and stationary wave. Whenever energy present in this region is transferred to the next region, we call the wave to be traveling wave. But sometimes waves behave like this. Energy in this region stays in this region. Energy in this region stays in this region. Energy in this region stays in this region. If there is no transfer of energy from one region of the medium to other region, if the medium is divided into regions of constant energy, regions which are not transferring their energy, then we say that in a medium we have set up transverse waves. Sorry, standing waves or stationary waves, not traveling waves. Standing waves, standing or stationary. Traveling waves means energy present in the one region is transferred to the neighboring region or the next region. But here, energy which is present in this region will stay in this region. So those waves are called as standing waves. Standing waves, more about standing waves we will learn in this chapter after some time. Now, any traveling wave has to satisfy this equation. Double partial derivative of y with respect to x is equal to minus 1 by v square into double partial derivative of y with respect to time. You can check the units also. d2y unit cancels with d2y. This velocity square on the left hand side. This dou x square and this dou t square. Units are balanced. You can check. There should be minus sign also. This should be the constant value square. So any function of position and time, y is a function of both position as well as time. So here we are writing partial derivatives. Any function of position and time that satisfies this equation is a wave equation or traveling wave equation. Now there can be waves of different varieties, but the very special wave is a simple harmonic wave. Means particles of this string can vibrate following different equations of oscillations. But if these oscillations are simple harmonic, then the wave itself is called as simple harmonic wave. Oscillations may not be simple harmonic. All oscillations are not simple harmonic. Only those oscillations in which restoring force is proportional to displacement and opposite to the displacement, these oscillations are called as simple harmonic oscillations. You need here x raised to 1, 2, 3, 4, 5, 6, not allowed. But there can be other kind of oscillations. In that case, obviously wave will not be called as simple harmonic wave. But there are cases in which particles of the medium oscillate simple harmonically. Then the wave will be called as simple harmonic wave. Now for simple harmonic wave, the wave function will be this. See, wave equation. If they say wave equation, you have to write partial derivative or differential equation you have to write. This differential equation means equation of wave, traveling wave. And y is a function of position and time. This is called as wave function. The very special wave function is y is equal to a sine omega t plus alpha plus or minus kx. Why this x term? Because oscillations are not only present at one location, they are present at all the locations. We need this x also. So this is a very special case of wave function. This is wave equation. All wave functions must satisfy this equation. And very special case of wave function. This is wave equation. Every wave function has to satisfy this equation. This is wave equation. These are wave functions. This is very special wave function. This very special wave function says particle oscillates or particle performs simple harmonic motion. This very special wave function says that particle performs simple harmonic motion. So we will call the wave as simple harmonic wave. Even if the wave is not simple harmonic, it has to satisfy this equation. Everyone has to satisfy wave equation. If you are a traveling wave, you have to satisfy this equation. And this is your speed or speed square. The speed at which the wave is propagating from one place to other place. A very special wave we studied. A sine omega t plus alpha plus minus kx, or a sine omega t plus minus kx, then plus alpha. What is amplitude of the wave? Amplitude of oscillation of particle itself is the amplitude of the wave. Phase constant alpha. Now, for oscillation of single particle, what is alpha? Alpha is the initial phase. What is initial phase? Initial phase is the angle corresponding to initial location. What can be initial location? Mean or extreme or any general. If it is mean, then alpha will be 0. If it is positive extreme, alpha will be 90. If it is mean and particle goes to negative extreme directly, then it is at 180. If initially particle is at negative extreme, then the phase will be 270 initial phase. But in a wave, it's not one particle which is oscillating. There are n number of particles which are oscillating. Then alpha represents initial phase of whom? Alpha represents initial phase of not all the particles. Alpha represents initial phase of particle at the origin. So alpha is what? Initial phase of particle at origin. Alpha is what? Initial phase of particle at origin. See, all these particles will start oscillation anywhere they want. They can start their oscillations anywhere they want. They can start their oscillations at mean or extreme. So all of these particles have some initial phases. But alpha represents initial phase of particle at origin. Phase constant alpha. Sometimes it is also called as phi naught. Naught represents initial phase. Phi represents phase. What is the phase of oscillation? Omega t plus alpha. But we are not having oscillation, we are having wave. So omega t plus alpha plus or minus kx. If you use plus kx, what does that mean? Wave is traveling in negative x. And if you use minus kx, the wave is traveling in positive x. Now, phase of the wave is this. Phase of oscillation was only this. Now, the phase of the wave is this. This kx term also required there. If you fix the place, no problem. This alpha plus kx will become a single constant. No problem. But whatever is written inside this sine function will be called as a phase. That is represented by phi. Angular frequency omega is defined as 2 pi upon time period. What is time period? Time after which wave repeats itself. But time after which wave repeats itself is time required for one oscillation of any one particle of the medium. Frequency of the wave is nothing but frequency of the oscillation of the particle. Rate at which wave repeat itself, or number of vibrations of the particle in 1 second. Number of vibrations, number of oscillations of any one particle. So in short, frequency of oscillation itself is frequency of wave. Amplitude of oscillation itself is the amplitude of the wave. Initial phase of oscillation itself is the phase constant of the wave. Angular frequency of oscillation itself is the angular frequency of the wave. Frequency of oscillation itself is the frequency of the wave. So all the oscillation parameters are directly assigned to the wave, because wave is nothing but n number of oscillations. Now similar to omega, they have defined this phase constant k. What was omega defined as? 2 pi upon t. Now they have defined k as 2 pi upon lambda. Wave repeats itself after definite interval of time. And if you take the photograph of the string at some instance of time, the string looks like this. So there is a definite distance after which wave repeats itself. Distance is lambda. This distance is called as wavelength. And this time is called as time period. So wave is doubly periodic in nature. It not only repeats itself in time, it repeats itself in distance, space also. It repeats itself in space also. How to check whether the wave repeats itself in space or not? Just take a photograph, you will fix a time. Check all the positions of the particle. Exactly this graph is available here. So you will say that wave is also repeating itself in space. The parameters like frequency, omega, time period are decided by the source. And the parameters like speed and wavelength, or to be particular speed, are decided by the medium. The medium will decide speed, and accordingly you have to satisfy which relation? Speed is equal to frequency into wavelength. Frequency has already been decided by source. Speed will be decided by medium, and lambda will be decided as a proportionality constant by both of them, you can say. So when I speak When I speak in air, frequency will remain same even if I change the medium to water. When I speak in water, when I speak in air, what will remain same? Frequency. And what will change? Speed and wavelength accordingly. Who decides the speed? Medium. Who decides the frequency? The source. Now again there are two kind of media. Media, plural of medium. There are two kind of media, or there are two types of medium. Dispersive and non-dispersive. What is dispersive medium? The medium which decides the speed of the wave based on its frequency. The speed is not same for all sound waves. Speed is different for different sound waves. In that case, medium will be called as dispersive. Air is a non-dispersive medium. So whatever words, whatever frequencies I am producing, all those frequencies, all the waves of all those frequencies travel with same speed. Air is a non-dispersive. Non-dispersive means for all the frequencies of the sound, speed will remain same. So speed is independent of frequencies or independent of wavelengths. Speed is fixed value. So स्पीड काढायसाठी फ्रिक्वेन्सीचा फॉर्म्युला स्पीड हा मीडियम प्युअरली स्वतःच डिसाइड करायला लागलाय. नाहीतर काय झालं असतं, मी जे बोलायला लागलोय त्यातले काही लेटर्स, काही वर्ड्स तुम्हाला आधी ऐकायला आले असते आणि काही नंतर ऐकायला आले असते. प्रॉब्लेम झाला असता. नॉन डिस्पर्सिव्ह मीडियम असल्यामुळे तो प्रॉब्लेम नाहीये. मीडियम डिस्पर्सिव्ह असेल तर प्रॉब्लेम आहे. डिस्पर्सिव्ह म्हणजे काय? फॉर different sounds of different frequency, medium provides different speeds. वेगळे वेगळे स्पीड जर दिले मीडियम तर काय होतं, त्याला डिस्पर्सिव्ह मीडियम म्हणतात. इव्हन तुम्हाला लाईटचं डिस्पर्शन माहित आहे. व्हॉट इज डिस्पर्शन ऑफ लाईट? द सेपरेशन ऑफ light into its component colors. Each color is a different frequency. ग्लास काय म्हणते कलरला? तुझी फ्रिक्वेन्सी काय आहे, कमी आहे जास्त आहे, त्या हिशोबाने तू वेगवेगळ्या स्पीडनं जायचं. सो दिस व्हाईट लाईट splits into its component colors. The white light splits into its component colors. आता सिक्वेन्स बघा, वरती व्ही आहे, खाली आर आहे, की खाली व्ही आहे, वरती आर आहे. What is this? Dispersion of the light. This glass is a dispersive medium. For a light, this glass is a dispersive medium. It says each frequency will have something different speed. All light waves will not have same speed in the glass. Basically, glass is a dispersive medium. Therefore, this white light separates into its component colors. More about it later. But air for the sound behaves as a non-dispersive medium. Air is non-dispersive medium for the sound. All sounds of all frequencies travel with same speed in the air. Wave velocity, particle velocity. What is wave velocity? Wave velocity is the phase velocity. What is phase of the wave? Omega t plus alpha plus minus kx. What is phase of a wave? What is wave equation? Simple harmonic wave equation. A sine omega t plus alpha plus or minus kx. This term is a phase of the wave. Now you can fix the phase of the wave. You can fix the phase of the wave as 90 degree. So right now this particle is at phase equal to 90 degree. After some time this particle will be at 90 degree. Means this phase has traveled. Or you can fix the phase of this particle at 180 degree. After some time you will observe that phase of this particle has become 270, but phase of this particle has become 180. So this phase 180 has traveled a certain distance. So you can fix the phase and check at what speed it is moving. Fix the phase. What is the phase? Omega t plus alpha plus minus kx. Now, if you take the derivative of fixed value, you will get 0 on the left hand side. This derivative with respect to time is omega. This alpha derivative is 0. Then this plus minus k as it is. X derivative with respect to x. Sorry, x derivative with respect to time is dx by dt. So what do you get here? 0 equal to omega plus minus kv. Rearrange the equation for v. You will get omega upon k. Forget the plus minus. What is speed of the wave? Omega upon k. If you solve this further, omega is what? 2 pi upon t. K is what? 2 pi upon lambda. So what does that mean? Lambda upon t. T is what? Period of one oscillation. When this particle completes one oscillation, wave travels a distance equal to wavelength. Distance traveled by the wave upon time taken by the wave. T is what? Time required for one oscillation. When one particle completes one oscillation, wave actually travels a distance equal to wavelength. So it is lambda upon t also. But what is 1 upon time period? Frequency. So what is speed of the wave? Frequency into wavelength. What is particle speed? What is happening to the particle? Particle is performing oscillations. So it cannot have a fixed speed. At the extreme, it will have zero speed. At the mean, maximum, zero. So particle speed is simply the derivative of y, partial derivative of y with respect to time. You can check these equations. Maximum particle speed is maximum speed of oscillation, which is a omega. Maximum particle acceleration is omega square a. Okay. Now slope of the wave. How to figure out slope of the wave? Plot the wave. How to plot the wave? Y position versus X position. These are the particles at different X positions. Now to check the Y position, you have to take the photograph. How to take a photograph? Fix the time. And notice positions of all the particles. Plot positions of all the particles. This particle is at extreme. This is at mean. This is at negative extreme. This is at mean. Now, slope of the wave means dy by dx, tangent to the curve. Not dy by dx, dou y by dou x. When you fix the time, you can take you can take partial derivative by fixing the time. The slope of the wave is related with particle speed and the wave speed. We have also derived the slope of the wave is negative ratio of particle velocity and wave velocity. This we have already derived. Yes or no? केलं होतं हे आपण हे केले का सॉल्व हे केले का हे झालंय का
क्वेश्चन नंबर 13 पर्यंत झालं
13 पर्यंत झालंय 14 झालाय का 14 करा an equation y is equal to a cos square 2 pi nt. 2 pi f omega is 2 pi f, 2 pi n. Here frequency is represented by the letter n. Okay. Minus 2 pi by lambda. 2 pi by t is omega. 2 pi by lambda is k. Propagation constant or angular wave number. K is known as angular wave number. Omega angular frequency. K angular wave number. This equation represents a wave with amplitude, frequency and wavelength. What is the amplitude here? What is the amplitude here? Hmm. What is the amplitude? Hmm? A by 2. How to represent this as A sin omega t or A cos omega t in the language of sine or cos function? We don't want this cos square function. We want sine or cos function. So what is replacement of cos square theta in the language of
1 plus cos upon 2.
what is replacement of cos square theta?
1 plus cos upon 2 theta 20.
1 plus cos 2 theta upon 2. This is cos square theta. 1 plus cos 2 theta. 2 theta means 2 in the bracket. One plus cos 2 theta whole divided by 2. This is the replacement of cos square theta. So what will be the answer? A by 2 plus A by 2 cos. This is what? 4 pi nt plus pi by lambda into x. Hmm? Minus 4 pi lambda into x. Now, this is basically equation of oscillation. Now, these oscillations take place about origin. This kind of question we have already solved. असं केलं होतं. This is what oscillation about origin, but this is what oscillation about position equal to 2. केलं होतं का? असा क्वेश्चन केला होता किंवा 4+ केलं होतं बघा. This is new mean position. If we write only this 2 sin omega t, what does that mean? If you write only 2 sin omega t, what does that mean? Oscillations are about mean position. So here your position will be 0, +2 and -2. But with this added 4, your oscillations will take place about 4. So here amplitude is 2 or a by 2 here, and oscillations are actually taking place about which position? a by 2. इथं जे काय तुम्हाला पोझिशन्स मिळणार याचे जे काय आन्सर्स असणार आहेत याचे आन्सर्स काय असणार आहेत? 0 असणार आहे, +a/2 असणार आहे किंवा -a/2 असणार आहे. म्हणजे हे ऑसिलेशन्स कुठल्या पोझिशनच्या अबाउट आहेत? 0. पण रियालिटीमध्ये या सगळ्या पोझिशन्स मध्ये काय ऍड झालाय? या सगळ्या पोझिशन्स मध्ये काय ऍड झालाय? a/2. मग मीन पोझिशन मध्ये पण a/2 ऍड करा. सो ऍक्च्युअली जे ऑसिलेशन्स होतील ते a/2 च्या अराउंड होतील. a/2 + a/2 a/2 + 0 a/2 a/2 - a/2 0. So actually oscillations are taking place about some other mean position than origin or than 0. So what is the amplitude? This a/2 is the amplitude and this a/2 is the mean position. Cos omega t or sin omega t, cos or sin doesn't matter. You can convert this cos into sin also. You can ask this sin cos function to decrease its phase by pi/2. It will become sin function. Or if you ask this sin function to increase the phase, means what? I can write this as a/2 plus a/2. I can write sin function as it is. And now I will ask this sin function to increase its phase by pi/2 because in reality we had cos function. In the question we had cos function. So we can ask this sin function to increase its phase. Now you can compare. What is the amplitude? a/2. What is omega? Coefficient of time is omega. What is omega? 2 pi. But what is our omega? 2 pi f. So from that, what is frequency? The frequency will be 2 times n. What is our wavelength? From comparison, coefficient of x is what? K. Coefficient of time is omega. Omega t k x. So after comparison, you will get k is equal to 4 pi by lambda. But as per our logic, k is what? 2 pi by wavelength. Let us call wavelength as lambda dash. So what is lambda dash? Actual wavelength lambda dash is not lambda. It is what? It is lambda by 2. So this is our wavelength. This is our frequency. This is our amplitude. And this is our new mean position. This is equation of oscillation but not about origin. All the particles are not oscillating about origin. The particles are oscillating about the position a/2. Clear? Now tell me, this wave is propagating in positive x or negative x? There is a minus sign here between omega and k. Between omega t and kx there is a minus sign. So it is propagating in positive x. But the positions of particles are represented by the letter y, means they are oscillating in y direction. So basically it is a transverse wave. Now to solve these kind of questions, you should be able to replace sine square and cos square functions. So for that, you need to remember these formulae. So write down cos 2 theta is equal to cos 2 theta is equal to cos square theta minus sin square theta. 2 cos square theta minus 1. 1 minus 2 sin square theta. And finally 1 minus tan square theta upon 1 plus tan square theta. Out of these four, we will use second and third formula. From this formula of cos 2 theta, you can figure out replacements for cos square theta and sin square theta. Using these two formulae, you can figure out replacements of cos square theta and sin square theta. So here we can write cos square theta is equal to 1 plus cos 2 theta whole divided by 2, and sin square theta can be written as 1 minus cos 2 theta whole divided by 2. Now remember this. This is how you will eliminate cos square and sin square and bring cos and sin. So our wave at given point of time will not look like this. It is not oscillating about origin. It is oscillating about a by 2. This position, y position, mean position of y is a by 2, not 0. So this wave is not represented by given equation. This is the wave represented by given equation. Y is not 0. Oscillations are not taking place about 0. Oscillations are taking place about a by 2. This is our current wave. Solve this.
Option B.
Second option. A simple harmonic wave is represented by y is a function of position and time. A naught sine. Step 1 is multiplying whatever outside to the inside quantities so that you can get complete coefficients. This nu, this symbol is not V, this symbol is nu. For frequency, sometimes they use letter F, letter N, or letter nu, Nu. So 2 pi nu t minus 2 pi nu x by lambda. Or you can write 2 pi nu by lambda into x. Now you can compare this with the standard equation. What is our standard equation? A sine omega t. Right now minus, so minus kx 2 pi, not new, 2 pi by lambda. This new is not there. When you multiply this 2 pi inside. So step 1 is get complete coefficient of time and complete coefficient of x. Complete coefficient means nothing should be taken common. Everything should be inside the bracket. Only then you get omega and k. If maximum particle velocity, what is maximum particle velocity? Vp max is equal to 3 times the wave velocity. 3 times the wave velocity. Now for wave velocity you can write Vw or simply V, no problem. Then the wavelength of the wave should be, okay, wavelength of the wave should be. What is maximum particle velocity? A omega. Particle is oscillating. So its maximum velocity will be at the mean position. What is that? A omega. Should be equal to 3 times wave velocity. What is wave velocity? Coefficient of time upon coefficient of x. उलट असते ना, वेव वेलॉसिटी काढताना उलट करायचं होतं. ओमेगा अपॉन के, कोएफिशिएंट ऑफ टाइम अपॉन कोएफिशिएंट ऑफ एक्स. Omega omega cancel. Amplitude A is equal to 3 times. What is K? K is 2 pi by lambda. So what is lambda? 2 pi A by 3. 2 pi is 2 pi. A is what? A naught. So first find out answer in our symbols, then convert our symbols into their symbols. Solve this. Do you understand the previous question? पार्टिकलच्या ऑसिलेशनची मॅक्सिमम वेलॉसिटी जी होती ती वेव्हच्या वेलॉसिटीच्या 3 टाइम्स होती, म्हणजे फेज वेलॉसिटीच्या 3 टाइम्स होती. नो प्रॉब्लेम. The displacement y in centimeter, okay, produced by the simple harmonic wave is given by 10 by pi. So this 10 by pi must be in centimeter because sign is unitless. 2000 pi into t minus pi x. So let us write pi by 17 into x. The period and maximum velocity of the particles in the medium are respectively period and maximum velocity of particle. Okay, what is period? 2 pi by omega. What is omega here?
2000 pi.
2000 pi. So it is simply 10 raised to minus 3 Second, Vp max, maximum particle velocities in oscillation, it is omega into root of a square minus x square. Put x equal to 0, mean position, you will get a omega. A is what? 10 by pi. It is in centimeter. Omega is in radian per second. Forget the radian, you will get centimeter per second. So that will be 20,000 centimeter per second. So 200 meter per second. Solve this. नाही कळलं की तुमचं तुम्ही विचारायचं, पट 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 पुढे जातो, याचा अर्थ असा नाहीये की नाही समजलं तरी पुढे जायचं. ऑनलाईन वाली बाकी लोक कुठे आहेत? दोनच आहेत. आलं काही?
Option A.
Option first, simple harmonic wave having amplitude A and time period t represented by the equation y is equal to phi sine pi in the bracket t. So take the pi inside, in परत 4 pi meter, amplitude is in meter, this time period or t is in second. Okay, everything is in standard units, so no problem. A किती आणि t किती? Basically this is not equation of wave, this is what? Equation of oscillation. So why they are calling this as equation of wave? What they might have done is they might have fixed the position. त्यांनी x ची व्हॅल्यू सबस्टिट्यूट केलेली आहे, त्यामुळे तो x दिसत नाहीये, किंवा ओरिजिन वाल्या पार्टिकलचं ऑसिलेशन लिहिलं असेल. डझंट मॅटर. टू फिगर आउट एम्प्लिट्यूड राईट नाउ कम्पेअर दिस विथ a sin omega t plus whatever phase you have or whatever you want to write. Alpha kx लिहू नका, अल्फा लिहा, x equal to 0 टाका. So amplitude will be phi. To figure out time period you will write 2 pi by omega. What is value of omega? It is pi. So answer is 2. Okay, so what do you understand from these questions? Solving questions of waves is more about solving questions of oscillations once again. So there is nothing new in this part. Solve this. So oscillations, waves, alternating current, हे सगळं एकत्र पाहिजे होतं. पण एनसीईआरटी मध्ये 11th मध्ये ऑसिलेशन्स आणि वेव्स दिले आणि 12th मध्ये अल्टरनेटिंग करंट दिलाय. पण आपण ते एकत्र कव्हर करणार सगळं.
B option.
Done. When a plane wave train ट्रान्सव्हर्सेस म्हटले, ट्रॅव्हर्सेस पाहिजे. ट्रॅव्हर्सेस अ मीडियम, individual particles execute simple harmonic motion given by the equation y equal to phi sine, take that pi by 4 inside, pi t plus pi by 64 into x. Always write complete coefficients of time and position, step 1, so that you can get omega. Omega is not 4. Omega is what? Omega is not 4. Omega is pi. You have to multiply this inside. Only complete coefficient of time will give you omega, and complete coefficient of x will give you k. Lengths are expressed in centimeters, all right, and time is in second. The phase difference for the two positions of the same particle, okay, fix the particle. Now, if you fix the particle, right now its phase will be 0 after some time, 90, 180, 270, 360. So particle's phase is changing with the time. If you fix the position, then you will see the particle oscillating. If you fix the position, you will see particle oscillating. And if you fix the time, you will see all the particles at different locations. You will not see anyone oscillating because you have fixed the time. You will see this particle is at 0 phase, this at 90, this at 180, or this at 270. So phase changes not only with the position, it also changes with the time. If you fix the particle, phase changes. If you fix the time, phase changes. So phase can change both with time and position. The phase difference for two positions of the same particle. Okay, you have fixed the particle. The phase difference for the two positions of the same particle which are occupied at a time interval of 0.8 second. What is time difference between the two positions? 0.8 second. Now you tell me, after time equal to one time period, what will be the position? Again the same location. Means what will be the phase difference? 2 pi. So for time equal to t, what is the phase difference? 2 pi. For time difference equal to capital T, what is the phase difference? 2 pi. In one time period, particle covers an angle, covers a phase of 2 pi. Then in the given time interval, what is the phase difference? You know, phase difference is equal to total phase difference upon total interval into your interval. This is the formula. I think I have already given this formula to you. Similar can be done if you fix the time and check the positions. Then also you can calculate the phase difference. If you move by a distance equal to lambda, phase changes by amount equal to 2 pi. Then if you move by distance equal to delta x, phase changes by amount equal to delta phi. So what is delta phi? Total change in phase upon total distance traveled into your distance. This distance traveled is called as path difference. This is called as phase difference. This is called as time difference. This is called as phase difference. So in this question, you have to use this. Let us use it. So what is the phase difference? Total phase change upon total time into your time. So 2 pi upon capital T. Now answers are in degree. So let's write 360 here. Degree. 2 pi radian is 360 degree. Time period is what? Let's not do it like this. What can be done? What is this 2 pi by T? What is this 2 pi by T? It's omega. It's omega into delta T. Omega is available directly. What is omega? It's pi. So pi into delta T. What is delta T? What is delta T value you have? 0.8. So this is 0.8 pi. Of course, answer is in radian. You know, pi radian is what? 180 degree. So always replace pi as 180. You will get answer in degree. फक्त काय करायचं लक्षात ठेवायची गरज नाही इंटू पाय बाय 180 किंवा इंटू 180 बाय पाय पाय रेडियनला 180 डिग्री न रिप्लेस करा. That's it. So what is the answer? 144 degree. Solve this. कोणती कुठलं ही वाली phase difference. Let's say the particle starts at phase equal to 0. Now, after time equal to t by 4, its phase will become 90. After time equal to t by 2, its phase will become 180. After 3t by 4, 270. And after total time t, its phase will become 360. So in time equal to capital T, phase changes by 360 or 2 pi. Then in time equal to delta T, phase changes by what amount? So phase changes by what amount is total change in phase upon total time into your time.
Option
याचा ऑप्शन डी आलाय का नाही नाही काहीच आलाय काहीच येत नाहीये काय येत नाहीये बघा at a moment in a progressive wave at a given moment a particle executing simple harmonic motion या particle ची phase किती आहे pi by 3 आहे in the phase of the particle which is 15 centimeter ahead okay हा कुठं आहे 15 सेंटीमीटर ahead आहे याची phase विचारतात सो हा गॅप किती आहे 15 सेंटीमीटरचा गॅप आहे मग याची फेज किती असेल असे विचारतात अँड ऍट टाइम टी बाय 2 त्याच वेळी नाही पार्टिकल ही सिच्युएशनच वेगळी आहे या पार्टिकलची फेज आत्ता किती आहे पाय बाय 3 सो टाइम इक्वल टू 0 ला सिच्युएशन ही आहे तुम्हाला याची फेज विचारली कधी टाइम इक्वल टू टी बाय 2 ला विचारली सो 2 पार्टिकल्स आहेत. याची फेज π/3 आहे. कधी? ऍट टाइम इक्वल टू 0. याची फेज किती असेल ऍट टाइम इक्वल टू t/2 विचारताय. आणि दोघांमधलं डिस्टन्स डेल्टा एक्स म्हणू आपण. दिले ते किती दिले? 15 सेंटीमीटर दिले. पहिला या दोघांमधला फेज डिफरन्स सांगा. आता यांच्यामध्ये फेज डिफरन्स असणार 2 रिझन्स मुळे. पहिलं रिझन आहे पाथ डिफरन्स. पाथ डिफरन्स असल्यामुळे फेज डिफरन्स आला. पाथ डिफरन्स काय आला सांगा? 15 सेंटीमीटर. पाथ डिफरन्स मुळे फेज डिफरन्स किती येणार? टोटल चेंज इन फेज अपॉन टोटल पाथ इफ यू मूव बाय अ डिस्टन्स इक्वल टू लॅम्बडा. फेज कितीने चेंज होते? 2π ने चेंज होते. व्हॉट इज युअर डिस्टन्स? डेल्टा एक्स. सो व्हॉट इज दिस? 2π by lambda. Lambda is 60 सेंटीमीटर. Your path is 15 सेंटीमीटर. सो फेज कितीने चेंज होणार? π/2 रेडियन न चेंज होणार. पहिला फेज डिफरन्स. दुसरा फेज डिफरन्स किती आला? टाइम डिफरन्स पण आहे. टाइम मुळे किती आहे? टोटल चेंज इन फेज अपॉन टोटल टाइम इंटू युअर चेंज इन टाइम. तुमचा टाइम डिफरन्स किती आहे दोघांमध्ये? त्याच वेळी याची बघायची आहे का? त्याच वेळी बघायची नाही. त्याच वेळी बघायची असती तर डायरेक्टली आन्सर आला असतं π/2. मग तुमचं ऑप्शन हे आलंय का बघा. ज्यांचं मॅच नाही झालं त्यांनी कदाचित ऑप्शन हे काढला असेल. त्याच इन्स्टन्सला काढलंय तुम्ही. टाइम फिक्स केलाय असं केलं तुम्ही चुकून. टाइम ऍक्च्युअली फिक्स नाही आहे क्वेश्चन मध्ये. त्याच वेळी याची किती असं नाही विचारली, थोड्या वेळानंतर याची विचारली. तर त्याला पोझिशन पण वेगळी दिली. दोन्ही फिक्स नाही आहे. दोन्ही चेंज होत आहे. पोझिशन पण चेंज झाली आहे, टाइम पण चेंज झालाय. सो इंटू t/2. सो हे किती आलं? पाय. कळलं का? आता हा अहेड वाला पार्टिकल आहे, पुढचा आहे, पुढे आहे. म्हणजे त्याची फेज लॅगिंग असणार. किती अमाऊंट? टोटल फेज लॅग जो येणार त्याचा पुढच्याचा तो किती येणार? टोटल फेज लॅग जो येणार पुढच्याचा तो किती येणार बघा. दोघांची ऍडिशन करावी लागेल. किती येत आहे? π/2 प्लस पाय म्हणजे किती होत आहे? कॅल्क्युलेशन काय चुकलंय का आपलं? π/2 आलंय. जरा चेक करा काय चुकलंय का. नाही बरोबर आहे, सगळं बरोबर, सगळं बरोबर आहे. सांगतो मी तुम्हाला. आता या दोघांमधला आपण काय काढला? फेज डिफरन्स काढला. त्यांनी फेज डिफरन्स नाही विचारला, नीट वाचा. काय विचारले? फेज ऑफ द पार्टिकल. या पार्टिकलची फेज विचारली. काय विचारली आहे? या पार्टिकलची फेज विचारली. कळतंय का? या दोघांमधला गॅप कळाला का आपल्याला? गॅप कळाला. आता जो आहेड असणार, समजा वेव इकडं चालली म्हणूया आपण, किंवा इकडं, कसंही घ्या. एक तर राईटला चालली किंवा लेफ्टला चालली, कशी घ्या. समजा राईटला चालली आहे म्हटली तर काय होणार बघा. आपण याला काय म्हणूया? पार्टिकल ए म्हणूया, आणि याला काय म्हणूया? पार्टिकल बी म्हणूया. सो फेज ऑफ पार्टिकल ए, फेज ऑफ पार्टिकल बी. ठीक आहे. सो फेज ऑफ पार्टिकल ए जास्त असणार मायनस फेज ऑफ पार्टिकल बी, आणि यांच्यामध्ये फेज डिफरन्स किती आलाय आपला? 3π/2 आलाय. असं जर आपण केलं तर फेज ऑफ पार्टिकल ए होती किती? π/3. फेज ऑफ पार्टिकल बी पाहिजेल आहे, आणि हे काय आलं? 3π/2. सो फेज ऑफ पार्टिकल बी किती आली बघा? π/3 म्हणजे 60 मायनस 270. 60 मायनस 270 किती आलं? किती आलं? 2π मायनस 3π. 2π मायनस 3π किती आलं? मायनस पाय अपॉन 6.
2π
मायनस पाय बाय
minus
6 आलं.
6π.
कळलं का?
So 2π minus 6π होईल.
2π मायनस
9π
2π
sorry.
मायनस 9π म्हणजे किती येणार? बघा तुम्ही सगळ्याला होय म्हणताय, कॅल्क्युलेशन तुम्ही करतच नाहीये. 2 पाय मायनस 9 पाय म्हणजे किती होणार? मायनस 7 पाय/6 असा विचार केला तर आता वेव राईटला चालली असेल तर बी लॅगिंग असेल, कारण हा लिडिंग असेल, हा लॅगिंग असेल. आता वेव लेफ्टला चालली असेल तर तसाही विचार केला तर चालेल ना. समजा वेवच लेफ्टला चालली आहे तर काय कराल? त्या केसमध्ये बी ला लिडिंग घ्यावं लागेल. पहिला त्याचे ऑसिलेशन सुरू होतील, मग ए चे सुरू होतील, आणि यांच्यामधला फेज गॅप किती काढला आपण आता इथं? किती काढला होता? 3 पाय/2 काढला होता. सो त्या केसमध्ये काय आन्सर येईल बघा? फेज ऑफ बी च फेज ऑफ ए प्लस 3 पाय/2 करावं लागेल. फेज ऑफ ए दिली आपल्याला, किती दिली आहे? व्हॉट इज दॅट? पाय/3 प्लस 3 पाय/2. आता किती येते बघा? 11 पाय/6 येते. काय येते? 11 पाय/6 येते. करेक्ट केलं का बघा आपण? जर ऑनलाईन चेक करा आपलं काय चुकलंय का. मला वाटत नाहीये काय चुकलंय, तरी एकदा बघूया. आपली एक मिस्टेक झालेली असू शकते. आपण Δ∅1 आणि Δ∅2 ऍड केले ना, ते कदाचित टाइम वाढल्यानंतर फेज ऍक्च्युअली वाढते, पण डिस्टन्स मध्ये पुढे गेल्यावर फेज कमी होते. त्यामुळे Δ∅1 आणि Δ∅2 ची मे बी सबट्रॅक्शन करावी लागणार आहे, आणि आपण ती ऍडिशन केली. ती आपली एक मिस्टेक असू शकते. कळेल तुम्हाला लगेच. यांनी फक्त डिस्टन्सचाच विचार केलाय, टाइमचा विचारच केला नाही ऑनलाईन लोकांनी, आणि 5 पाय/6 काढलंय. फक्त डिस्टन्सचा विचार केला. फक्त डिस्टन्सचा विचार केल्यावर किती आलं होतं आपलं? फक्त डिस्टन्सचा विचार केल्यानंतर फेज डिफरन्स किती आला होता? पाय/2 आला होता का? फक्त डिस्टन्सचा विचार केला तर जे गॅप या दोघांमध्ये कितीचा आहे? तेच की, फेज डिफरन्स पाय/2 चा आला होता. याची फेज किती दिली होती? पाय/3. गॅप कितीचा आहे? पाय/2 चा. मग याची किती? एकतर सबट्रॅक्ट करा, नाहीतर याला लिडिंग म्हटलं तर ऍड करा. ऍड करा बरं, किती होतंय? पाय/2 प्लस पाय/3. कारण हा लिडिंग पण असू शकतो ना, वेव्ह जर तिकडनं येत असेल तर. वेव्ह जर लेफ्ट येत असेल तर लिडिंग पण असू शकतो. मग त्या केसमध्ये ऍड करा. आता होते का बघा 5 पाय/6. मग ते 5 पाय/6 त्यांनी जे काढले ना, ते कसं काढले? फक्त डिस्टन्सेसचा विचार करू. मग डिस्टन्सेसचा फक्त विचार केला तर टाइम इन्स्टन्सेस सेम झाले. मग आपण असं म्हणूया की याची जी काय फेज होती ती टाइम इक्वल टू 0 ला पाय/3 नव्हती, टाइम इक्वल टू T/2 लाच याची पण पाय/3 होती, आणि त्याची पण T/2 लाच. म्हणजे दोघांची कुठल्या टाइमला काढायची आहे? T/2 म्हणजे टाइम डिफरन्स दोघांमध्ये काही नाहीये. आलं का लक्षात? सो याला आता तुम्ही काय चेंज करा सांगतो. पहिल्याची फेज तुम्ही जी लिहिली आहे ना, ती इथं तुम्ही लिहिलं होतं बघा. इथं काय लिहिलं होतं तुम्ही? ऍट टी इक्वल टू 0 लिहिलं होतं, बरोबर का? इथं टी इक्वल टू 0 लिहू नका. याची जी फेज आहे ना, ती π/3 लिहा. आणि इथं तुम्ही ऍट टी इक्वल टू 0 लिहिलं होतं तसं लिहू नका. तो टाइम इन्स्टन्सच काय घेऊया? T/2 घेऊया. दोन्हीचे टाइम इन्स्टन्सेस सेमच आहेत. सो हा डेल्टा टी वाला पार्ट किती घेऊया? 0. म्हणजे इथनं काय ऍड झाला नाही, हे चेंजेस करा आणि मग तुम्हाला जे उत्तर पाहिजे ते उत्तर मिळते बघा. कळलं का बघा? फेज डिफरन्स π/2 चा आला. फेज डिफरन्स या दोघांमध्ये जर π/2 चा आला तर पहिलं पॉसिबल आन्सर काय आलं बघा? पहिलं पॉसिबल आन्सर काय आलं? 2π - 3π म्हणजे -π/6 पहिलं पॉसिबल आन्सर. आणि दुसरं पॉसिबल आन्सर काय लिहिणार आता? चेंज करा सगळीकडे. फेज डिफरन्स किती घ्या? दुसरं पॉसिबल आन्सर किती येणार मग आता? 5π/6. कळालं? म्हणजे ते ऍक्च्युअली टाइम डिफरन्सेस नव्हते. एकाची फेज 0च्या टाइमला आणि एकाची फेज T/2 टाइमला असं नव्हतं. तर ते काय होतं? दोन्ही टाइम इन्स्टन्सेस T/2 असेच होते. तो ऍट टाइम T/2 जो आहे तो फक्त पुढच्याचा नाही आहे, तो दोघांचा आहे. असं काहीतरी असणार आहे. मग 5π/6 येत आहे. थोडंसं आम्हाला काय करावं लागेल? आमचं आन्सर ऑप्शन मध्ये 11 कुठंच दिसत नव्हतं. बरोबर ना? आपण जे काढलं होतं 11π/6 कुठंच नव्हतं. मग आपण तो विचार करायचा की कदाचित मग टाइम काय असतील? सेम असतील. असा काहीतरी विचार करावा लागेल. कारण त्यांनी जे दिले त्याच्यावरनं तर अर्थ असाच निघतो. हा, ऍट अ मुमेंट इन अ प्रोग्रेसिव्ह वेव्ह. आणि ती मुमेंटच दोघांची मुमेंट सांगितली T/2. त्यामुळे मुमेंट सेम झाली असं आहे ते. आणि ती जर डिफरंट करायची असेल तर मात्र तुला हा Δ∅1 आणि Δ∅2 आपल्याला सेपरेट काढला ना, तो काढावा लागेल. डिस्टन्स मध्ये पुढे गेल्यावर फेज कमी होणार, कारण वेव्ह आपण लेफ्ट कडनं यायला लागली अशी घेतोय. पण टाइम मध्ये तर फेज वाढतच जाणार. त्यामुळे ही कमी झालेली आणि ही वाढलेली, म्हणजे फेज डिफरन्स काढताना ऍक्च्युली या दोघांची काय करावी लागेल? सबट्रॅक्शन करावी लागेल. ते पण कराय. आपण जरा सबट्रॅक्शन करून बघूया काय काय होतंय. पहिली काय आली होती आपली? डिस्टन्स मुळे π/2 आली होती, बरोबर. आणि याच्यामुळे किती आली होती? टाइम मुळे किती आली होती? पाय आली होती. सबट्रॅक्ट करूया. π - π/2 म्हणजे परत किती येते? π/2 येते. तसं करून बघूया, ते जास्त बेटर आहे. आपण प्लस केलं होतं ना, त्यामुळे 3π/2 आलं होतं. डिस्टन्स मध्ये जेव्हा तुम्ही पुढे जाता तेव्हा फेज लॅग झाली, पण पुढचा पार्टिकल टाइम मध्ये जेव्हा पुढे गेला तेव्हा त्याची फेज वाढली. त्यामुळे इफेक्टिव्हली त्याची किती ना लॅग आहे, तर ती सबट्रॅक्शन करून काढावी लागेल. तसं केलं तरी चालेल, तरी पण π/2 येते. आणि ते π/2 पुढे जर आपण वापरलं तरी चालतंय. आलं का लक्षात? सो या क्वेश्चनला दोन्ही पद्धतीनं सॉल्व्ह करता येईल. म्हणजे मी जे म्हणतोय की एक टाइम डिफरन्स आणि पाथ डिफरन्स दोन्हीचा विचार करा. पण टाइम डिफरन्स मुळे आणि पाथ डिफरन्स मुळे तुम्ही त्या दोन्ही फेज डिफरन्सेस ऍड करू नका. काय करा? सबट्रॅक्ट करा. पाथ मध्ये पुढे गेलात तर पुढच्या पॉईंटची फेज लॅगिंग असेल, पण पुढचा पॉईंट टाइम मध्ये पण पुढे आहे ना, त्यानं आपली फेज वाढवली पण असेल. त्यामुळे ओव्हरऑल दोन्ही फेज डिफरन्सचा काय होणार आहे? सबट्रॅक्शन होऊन तुम्हाला आन्सर मिळणार आहे नेट फेज डिफरन्स. काय केलं कळलं का बघा? ऑनलाईन जे केले ते पण मी तुम्हाला दाखवलं. ऑनलाईन काय केलं त्यांनी? 5π/6 काढले, पण नुसता पार्ट डिफरन्सचा विचार केला. मग पार्ट डिफरन्सचा विचार केला तर दोन्ही टाइम्स आम्हाला काय घ्यावे लागतील? सेम. आणि दोन्ही टाइम वेगळे वेगळे घेतले तर पार्ट डिफरन्स मुळे टाइम डिफरन्स मुळे दोन्ही फेजेस काढा, पण या दोन्ही फेजेस काय करा? सबट्रॅक्ट करा. इथं साइन कुठलं टाकलं पाहिजे मी? सबट्रॅक्टचं टाकलं पाहिजे स्टँडर्ड. आणि मग तुम्हाला π/2 किंवा -π/2 मिळेल. तो तुम्ही इथं वापरा. मग इथं वापरा, एक आन्सर मिळेल. तिकडे वापरा, दुसरा आन्सर मिळेल. आणि मग तुम्हाला एक आन्सर 5π/6 मिळेल. मी काय बोललो कळलं का बघा? म्हणजे तेही करेक्ट आहे मी जे बोललोय ते. कारण तरी त्या केसमध्ये पण फेज डिफरन्स π/2 यायला लागलाय. शेवटी काय π/2 आल्याशी मतलब आहे ना. π/2 फेज डिफरन्स आला की पुढचं मॅच होणार आहे. कळायला लागले का बघा? सो असे पण काही ट्रिकी क्वेश्चन्स आहेत ज्यात आपल्याला सायमल्टेनियसली टाइम डिफरन्सचा आणि पाथ डिफरन्सचा विचार करावा लागेल. मग ते दोन्ही फेज डिफरन्सेस काढून सबट्रॅक्ट करून नेट फेज डिफरन्स काढायचे. परत त्यात तुम्हाला माहित नाही कोण लिडिंग आहे आणि कोण लॅगिंग आहे. त्यामुळे तुम्ही काय करणार, एकदा फाय बी मायनस फाय ए करणार आणि एकदा फाय ए मायनस फाय बी करणार आणि तुम्ही जो काय नेट फेज डिफरन्स काढलाय तो लिहिणार. कळलं का? हे त्याचं ऍक्च्युअल आन्सर झालं. ठीक आहे. तुमचं सॉल्व्हिंग काय काय चालू आहे जेई वाल्यांचं? ऑसिलेशन्स. तुमचं काय चालू आहे ऑनलाईन लोकांचं?
Recently
ऑसिलेशन
आम्हाला
चालू आहे की टेस्टचा
calculation
अभ्यास करताय?
चालू
टेस्टचा अभ्यास करताय? बरं, टेस्टचा अभ्यास करा. तुम्ही पण टेस्टचा अभ्यास करा. नीटवाले काय करतायत? टेस्टचा अभ्यास करतायत. ठीक आहे. टेस्ट जेव्हा संपतील तेव्हा पुढचा अभ्यास चालू करा. थांबूया. लिव्ह केला तरी चालेल.